Hello world, my name is Victor Engelmann, and in this video I want to discuss the Unified Extensible Firmware Interface, UEFI. And what's UEFI? It's one of two major methods to boot a computer. On my channel I have often discussed how the boot process of computers works, but there are two different ways, so the old way is the MBR way, using the master boot record, and UEFI is the new way, not that new. I think it's at least 15 years already, and it's been the standard on new computers for, I don't know, 10 years or so. The MBR way is simpler, and that's why I tend to talk about that more. Let's discuss the difference between the two before we then proceed to do something with these things in practice. So the old way, the master boot record, works like this. When you start the computer, the CPU talks to the BIOS, and then the code in the BIOS tells the CPU to talk to the hard drive, get the first sector 0, and the data in here is just some bytecode for the processor. Okay, so on an x86 machine, that's just some x86 binary code that the processor can execute, and it will then happily execute that, no matter what that is. Okay, and this is only 512 bytes, which is very, very small. So this already was a problem, because the code in here had to be really small to work. What that code typically did was it would tell the processor to look at the partition table at the end of the sector, and from there, and in that partition table you would then have information about, okay, I have a partition that starts here and goes until here. Okay, so you would have something like this. So an information, okay, one partition goes from here to here, and another partition goes from here to here, and so on. And the code in here really had to know about how this partition table looks. And then this code, this really small code, remember this must be really, really small. This code would then look at, for example, if this is my boot drive, it might look into /boot and load Grub from there, or Grub CFG. So typically this code here in the front would load some additional stuff from the hard drive, and that would then look at things like the Grub CFG or something to display your boot menu. Okay, this worked not too bad, but as I said, 512 bytes is really, really small. That was one problem. Then the offsets couldn't be too big, so I think more than 2 terabytes would be too much for it, and also I think the boot partition would have to be within the first 2 gigabytes, which would also be a problem. But the biggest problem was if you had multiple operating systems in parallel, because yeah, you have one operating system here, one operating system you install later here, and then the new operating system will just wipe the bootloader of the old operating system. Yeah, typically Linux systems would figure out ways to coexist with Windows systems, for example, but Windows systems really didn't care about other systems. So if you installed a Windows system, it would just bootloader gone. And yeah, Linux systems at least would take the old bootloader, put them somewhere, and would then be able to chain load that. But yeah, anyhow, not really elegant, and yeah, just loading some code from sector 0 and executing that no matter what it is. Yeah, that was just a bit unelegant. And yeah, then UEFI was designed. UEFI works a bit differently. You again have, I think it's also just sector 0. So again, only 512 bytes. But yeah, here you could have any code you want, and the code in here just would have to understand the partition table here, okay? And yeah, in UEFI, people said, okay, we have pretty good file systems. We don't need to have this this hand waving. It just has to know itself. We'll just have one particular partition, which has to be FAT32 formatted, and yeah, in there you will have a directory EFI, and yeah, under that you have something like Microsoft or Ubuntu and so on. So every operating system can just put itself in a subdirectory of this EFI directory. And yeah, this first sector would just be a partition table without any bytecode in here. It's just a GPT partition table. That's important. It must be a GPT partition table, and yeah, the firmware of the mainboard now that is loaded at the start must now do all the stuff that would have been done here by this arbitrary code. Okay, so the firmware of the mainboard must understand GPT partition tables to find out where is my boot partition, and the firmware of the mainboard must understand FAT32 file systems so that it can look into these directories, and in here you will then find something .efi files, and these are multiple bootloaders, so you can have multiple bootloaders in these subdirectories. Okay, so let's do something practical with this. Okay, I've prepared a system that is installed with MBR Booting, and we will translate that to a system that operates on UEFI Booting. And yeah, without reinstallation, we will just take the system, change the way it boots, and the system itself will keep untouched, so so without data loss. And yeah, the stuff that you will see there is will also be very helpful if you ever break your bootloader, if I don't know, if you accidentally delete your boot drive or whatever. So yeah, let's look into that. So I have prepared this operating system here. This is an Endeavour OS running inside a virtual machine because I don't want to mess with my actual hardware right now. But yeah, the steps are pretty much the same. So yeah, before we start, I'm personally not a person who uses fail safes a lot, but yeah, when you're dealing with your partition tables and file system tables and stuff, then you really should take a backup of your hard drive and at least of your files. And as I said, I'm generally not somebody who does that, even if it's recommended. In this case, when I actually did that, yeah, I pulled an old hard drive out of the basement and actually made a backup of my hard drive. And I mean, this is a really slow hard drive, so this took like 7 hours. But yeah, in such a risky case, I really didn't want to do that without a backup on my primary machine. So if even I did that, that should be some indication for you that then you should do that also. Okay, so now let's look at this operating system here, and yeah, let's start. Okay, Gparted is not part of the standard installation. Okay, here is Gparted. Now, as you can see, I have this one hard drive here, 12 gigabytes, and if I set it to show additional information, then you can see here this is an MS-DOS partition table. So so yeah, this is an MBR system, and you can check that if you look at this firmware UEFI. Okay, doesn't exist, and that's because yeah, this is booted using the MBR method. If this was booted using UEFI, then we would have this directory here, but it isn't there because this system was not booted using the UEFI method. Okay, so what I'm going to do now is I will turn this system off. Okay. And what I will do now is I will go here to the settings system and tell it to use UEFI for booting. And yeah, if you do this on actual hardware, this would be a setting in your BIOS. And yeah, that depends on your mainboard how that works. So you would just have to look into your BIOS settings and look for something that tells you, hey, I want to turn on UEFI Boot-method. Okay, and now I will go to mass storage here and tell it to use as an optical drive this live system for Endeavour OS. Okay, start. Now I get this boot menu here that allows me to boot from the live medium in UEFI mode. Okay, now in this live system, the first thing I want to do is I will change the type of the partition table from MS-DOS to GPT. And you do that using the program gdisk. Okay, SDA is the hard drive, and yeah, it tells us it has only found an MBR partition table. That makes sense. With the command question mark, you get this list of commands, and with W, we can now write this GPT partition table that gdisk has already generated to the disk. Confirm with Y. Okay, and it has written the partition table to the disk. Now at this point, we don't have a bootloader anymore, so if I would reboot this machine now from the hard disk, it would just tell me I haven't found a bootloader, I cannot boot. Okay. So yeah, the next thing we need to do is we need to give it a new bootloader. And to do that, I will use gparted again. So here is this partition with our root file system. I would now move it to the right. 100 megabytes should be enough, but I will go to 1 gigabyte. Just for good measure. And then here in this free unallocated space that we now have, I will create a new partition, which I will call UEFI of type FAT32. Okay, edit, apply all operations, apply. And yeah, this will take a while now because what this is now doing is it's moving all the files here, this yellow stuff, to the right. So it has to move all the files, and yeah, that will just take a while. We could have put this additional partition behind our partition here, and that would have been faster, but yeah, I don't know. This is just something that comes from the old MBR days when an MBR boot partition had to be in the first 2 gigabytes of a drive. It just feels wrong to me to put a boot partition at the end of a disk, you know. Oh, it seems to have finished already. That was relatively fast. Okay, so now we have a partition. Right now it's just an empty partition. We haven't put the bootloader there yet. Oh wait, I forgot something. Need to go back to gparted, and yeah, this partition here, this new partition, must get the ESP flag, and that also checks the boot flag, okay? Because otherwise the mainboard will just not even try to boot from that. Now to actually put the bootloader into this drive, we need an UEFI compliant Grub. Since this system was booted in UEFI mode, I'm pretty sure that the Grub that we have here will support it, but depending on your system, this might be something that you have to install before. So so I've logged in as root now, and I will mount the first partition to MNT. Okay, and in there we have the boot directory, and yeah, this boot directory doesn't contain much. You see it does contain a directory grub, and yeah, an initramfs, a fallback initramfs, a kernel, and yeah, we don't have this typical directory boot UEFI, so I will just create that. Okay. And this is where I will now mount the other partition. Good. We will need to change root into this MNT drive, which is our root drive. But if we do that just like that, then we will lose access to the dev directory, for example. So very similar to what we did in the Linux from scratch videos, we first need to mount some of our directories from this live system into this root drive. So mount bind dev to MNT dev, for example. Okay. And we do the same thing with this. And proc. And also run for good measure, but I think we don't even need that. Okay, and now we can change root into that. Good. So now at this point, we are kind of like, at least inside this bash session, we are kind of like logged into our primary system. So if we start any programs, they will be taken from that primary system. Okay. And yeah, now what we can do is we can reinstall Grub. Grub install. So target x86-64-EFI. I think we wouldn't actually need that parameter because we have booted this in EFI mode, so that should be the default selection anyways, but to make it sure, I put it here. And we will install that on dev SDA. The EFI directory is boot EFI. I think this is the default directory anyways, but you can set it like this if you want. EFI variables not supported. Failed to register the boot entry, no such file or directory. I'm not sure if that's a bad sign. I will redo it again with --force. Okay. So it has done something. It's created the directories EFI, Endeavour OS, and in here grub x64.efi. That doesn't look too bad. I don't know why it's complaining that much, but okay. That doesn't look too bad. I think we should be able to boot from that. Yeah, let's try. Let's reboot. Okay, I checked the live medium, reset the system. Okay, it looks like the installation has failed, so I will put the live medium back in, restart. Good. Maybe the problem was that, I mean, we had an error message, right? So maybe the problem was that I did the change root first, so we were using the Grub from the system that was an MBR system. So maybe do the Grub install from the live system, and then maybe that will improve things. Okay. Target x86-64 UEFI. Reinstall to dev SDA. Now we are using non-standard directories, so now we have to set this. No error reported, that's looking better. Okay, let's try again. There. This does not look like the live medium. The live medium is not plugged in, so yeah, this is booting from the hard drive. So let's look into a few places. Here, SDA1 is mounted on root. Yeah, that looks good. Okay, it hasn't mounted boot UEFI. Let's make an entry for that in the file system table. Okay. Let's see. Let's let's look into LSBLK, name and UUID. So this here is SDA1, this is the UUID of SDA2. We'll copy that and make an entry here in the file system table. Yeah, this has obviously worked. There's our bootloader. Okay, and now that we have that, let's see, ls this firmware EFI. You see, now that we have booted from EFI, we have this directory here in this firmware EFI, and now there's stuff there. Yeah. Okay, yeah, this is really cool. So we have taken an MBR system and transitioned it to an EFI system. And yeah, I think that's a pretty good thing because, I mean, EFI is really the standard today. You know, it's faster, it's not that fragile. You know, when you install a new operating system, you don't remove the old bootloader and then have to hope that that you're not breaking all the other systems, you know. So with EFI, it's easier to have multiple systems in parallel, you know, without risking to break everything. So yeah, this is all I wanted to show you today. If you like this video, like it, share it, subscribe, and see you next time.